Hey geometry geniuses, we're going to be taking a look at the next section, 8.6, dealing with law of sines and cosines. What's cool about this section is that we don't necessarily have to work exclusively with right triangles anymore. With law of sines and law of cosines, we're able to solve for angle measures and side lengths now in any triangle. This video will most likely just cover law of sines. So be on the lookout for the next video on law of cosines, which should be the next section. We'll start first with law of sines. Let's do this. So this is saying that if we have an opportunity in a triangle to have two angles and a side length, considered angle, angle, side, or angle, side, angle, or another option we can come across, we can have two sides and a non-included angle, referred to as SSA. Be careful there. We can solve for our two side lengths using what is called the law of sines. So this is helpful when we're missing side lengths. As we see here, the ratio for the sine for each angle and its opposite side is constant, which allows us to say that these three ratios hold true, where if we take sine of angle A and divide that by side length A, so angle A is up here, do my best to color coordinate here, small a is down here, that should be equal to sine of angle B over side length B. So notice it's a mix of angles and then side lengths, and that should also be equal to sine of angle C dividing by side length C. And all three of these fractions or ratios should be equal to each other if we do this correctly. This is a big technical area. If you want to take a look at how law of sines work, it's up to you though. As we mentioned before, we use law of sines in two specific situations: when we're dealing with two angles and any side, or two sides and an obtuse angle that's opposite one of them. Obtuse, of course, being more than 90 degrees. So let's look at this first example here. We have this triangle. It's definitely not a right triangle, but we do have three angles inside. Notice 1, 2, 3. So based off of law of sines, we're allowed to say the following. Well, we'll only fill in one of these fractions, but we're allowed to say that if we were to take sine of angle 36 and divide that by 8, that should be equal to what other ratio? What do you think? That should be equal to sine of, well, you have some options here. You could take sine of 48, which is here, and divide that by b. That's an option. And eventually we could fill in that other fraction, and we will do that in time, but for now, let's just go ahead and solve for b. So how can we break this fraction down? What do you think? Well, we have fractions on both sides, or ratios. If we cross multiply, this will allow us to say something to the effect of b, when multiplied with sine of 36 degrees, that should be equal to 8 times sine of 48 degrees. And I'll do my best to color coordinate here. So what do you think? How can we take this further and solve for b? Hopefully you're saying divide both sides, but divide both sides by what? Hopefully you're saying sine of 36. Sine of 36 would cancel here, and then this should be approximately b. And if we have our calculator set in degrees, not radians, this should say that b is approximately 10.11 units. Cool. Seem easy enough, right? All right, well, let's take this back and see if we can solve for C, because now that we have B, this part's done. We already have A, we're missing C now. So let's take this back. Cool, so let's get rid of this one. And the reason I'm holding on to this fraction here is because I know what the angle is and I know what the side length is. So I want to hold on to that as I go towards the next fraction. So let's do this. So the fraction that we're missing or haven't talked about yet would involve C, which is saying sine of 96 degrees when divided by C should be equal to sine of angle A over A. Let me color coordinate this a little bit. Cool. So same kind of song and dance as we saw before. We can cross multiply. This will get us C multiplying with sine of 36. And that should be equal to 8 multiplying now with sine of 96 degrees. Simple. All right, same thing. How can we solve for C? We can divide both sides. Again, divide both sides by what? Sine of 36. Simple. And so this allows us to then use our calculator to compute what C should be. And if we take this into our calculator, being careful to use parentheses and divide accordingly, this should give C as approximately 13.54 units. So lo and behold, we solved for our missing side lengths. Simple enough.